Hello everyone, this is a very important video. In this video, I will cover 4 points. वो 4 points क्या हैं समझते हैं. Our first point is shear span. Our second point is point of contraflexure. Our third point is focal length. At last, I will cover the concept of internal hinge. This question is very important. Shear span question has been asked in ESE 2010. Point of contraflexure has been asked in ESE 1997, 2002, 2004, 2016. It has also been asked in IAS 1996, 2002. तो इन कंसेप्ट को समझते हैं. Our first point is shear span. Shear span को समझते हैं. The portion of the beam in which shear force is constant is known as the shear span. The portion of the beam in which shear force is constant is known as the shear span. Shear span को समझने के लिए I have drawn a simply supported beam subjected to a point load at the center. इस टाइप की बीम के लिए इसका SFD looks like this. This is the SFD, that is the shear force diagram for this particular beam. Now, इस shear force diagram में I am looking this span or this span. In this particular span, the value of shear force is constant. Although shear force has the value of P by 2 in between this span, but this value of P by 2 is constant from this point to this point. That's why this span is known as the shear span. Similarly, in this case, here the value P by 2 is constant from this point to this point. So this portion is known as the shear span. Always remembering this point, shear span is the portion of the beam in which shear force is constant. वो क्वेश्चन में आपको ऑप्शंस देगा that the shear span is the portion of the beam in which shear force is 0 or shear force is constant. So must be remembering this concept that in the shear span, shear force is constant, not the 0. Shear force is constant. Okay, our next point is point of contraflexure. Point of contraflexure is the point where bending moment change its sign and the value of bending moment is 0. So the point where bending moment change its sign and as a result of which bending moment is 0 is known as the point of contraflexure. Point of contraflexure को better समझने के लिए I have drawn two shape. This is the first shape in which one end is fixed. At point B, roller support is provided. At C, roller support is provided. The end D is free, where a 4 kN load is applied. इस बीम का अगर हम एनालाइज करने के बाद BMD ड्रॉ करते, then the BMD for this beam looks like this. अब इस BMD को, that is a bending moment diagram को बहुत ध्यान से समझते हैं. इस bending moment diagram में bending moment ने अपना साइन 2 times चेंज किया है. कैसे? Bending moment change its sign from positive to negative at this point, and secondly, bending moment change its sign from negative to positive at this point. So these 2 points are known as the point of contraflexure. Point of contraflexure. क्योंकि bending moment ने अपना sign change किया है, that's why bending moment is also 0 at this point. So point of contraflexure is the point where bending moment change its sign. The bending moment change its sign is known as the point of contraflexure. Now, point of contraflexure को और बेटर तरीके से समझने के लिए हमने यहाँ पर एक और बीम ड्रॉ की है. दिस इज अ सिंपली सपोर्टेड बीम हैविंग अ पॉइंट लोड एट इट्स सेंटर. इस बीम के लिए अगर हम बेंडिंग मोमेंट डायग्राम ड्रॉ करें, then the bending moment diagram for this beam looks like this. Now, in this diagram, here the value of the bending moment is 0 and here the value of the bending moment is 0. तो क्या ये point of contraflexure है? क्या ये point of contraflexure है? आंसर है नहीं. This is not a point of contraflexure because for point of contraflexure the prime condition is that bending moment must change its sign, the resultant of which is that the bending moment is 0. So the prime condition for point of contraflexure is bending moment change its sign. This is not a point of contraflexure. This is not a point of contraflexure. Point of contraflexure से रिलेटेड क्वेश्चन बहुत ट्रिकी होते हैं. एक ट्रिकी क्वेश्चन जो कि IES में आया हुआ है उसको लेते हैं. Before moving to the question, let's understand one more concept here. That is, what is focal length? Focal length को समझते हैं. This is the focal length. So, the distance between two adjacent point of contraflexure is known as the focal length. The distance between two adjacent point of contraflexure is known as the focal length. अब क्वेश्चन को समझते हैं जो IES में आया हुआ है, उसका आंसर किस तरीका से हमको करना है. द क्वेश्चन रिलेटेड टू द पॉइंट ऑफ कॉन्ट्राफ्लेक्चर आस्क्ड इन 2016 ESE. देखते हैं क्वेश्चन क्या है. द क्वेश्चन सेज इन द एनालिसिस ऑफ बीम्स सब्जेक्टेड टू लोड्स द पॉइंट विद निल बेंडिंग मूवमेंट कैन बी अ. तो ये कह रहा है कि वो पॉइंट हमें बताइए जहां पर बेंडिंग मूवमेंट निल है, दैट इज द बेंडिंग मूवमेंट 0 है. उसने 3 ऑप्शंस हमारे पास दे रखे हैं. पॉइंट ऑफ कॉन्ट्राफ्लेक्शन, पॉइंट ऑफ मैक्सिमम शेयर फोर्स, पॉइंट ऑफ इन्फ्लेक्शन. इन तीनों के कॉम्बो के लिए उसने 4 ऑप्शंस हमारे पास दे रखे हैं. दैट इज द आंसर कैन बी ओनली 1, ओनली 2, ओनली 3 और ऑल ऑफ 3. इस क्वेश्चन का आंसर कैसे देते हैं हम? बिकॉज द पॉइंट ऑफ कॉन्ट्राफ्लेक्चर इज द पॉइंट वेयर द बेंडिंग मूवमेंट चेंज इट्स साइन एंड रिजल्टेंट ऑफ विच बेंडिंग मूवमेंट इज 0. हमारी पॉइंट ऑफ कॉन्ट्राफ्लेक्चर की डेफिनेशन के अकॉर्डिंग ये कोई भी ऑप्शन सही नहीं है. इस सिचुएशन में हम जाएंगे मोस्ट एप्रोप्रिएट आंसर पर, बिकॉज we have to answer this question with these options only. That is, we are bound to reply with only these 4 options. इसीलिए now we will switch to most appropriate answer. So the most appropriate answer for this question is point of contraflexure. That is this one. Although remember this one thing, that this is not the complete answer, but we are bound to reply this question. That's why we have chosen the most appropriate answer. That is the point of contraflexure. Got it? Now in this question, a term is introduced. That is the point of inflection. That is the point of inflection. तो ये point of inflection क्या होता है ये समझते हैं. पॉइंट ऑफ इन्फ्लेक्शन. पॉइंट ऑफ कॉन्ट्राफ्लेक्चर में बेंडिंग मूवमेंट अपना साइन पॉजिटिव से नेगेटिव की तरफ चेंज कर रहा था. एट द सेम पॉइंट इलास्टिक कर्व ऑल्सो चेंज इट्स कर्वेचर एंड दैट सेम पॉइंट वेयर द पॉइंट ऑफ कॉन्ट्राफ्लेक्चर अकर इज नोन एज द पॉइंट ऑफ इन्फ्लेक्शन. सो द पॉइंट ऑफ इन्फ्लेक्शन इज द पॉइंट where elastic curve change the curvature at the point of contraflexure is known as the point of inflection. सिंपलिसिटी में इसको समझ सकते हैं. अगर हम बेंडिंग मूवमेंट डायग्राम बना रहे हैं तो बेंडिंग मूवमेंट डायग्राम में बेंडिंग मूवमेंट अपना साइन चेंज कर रहा है. जैसे ही बेंडिंग मूवमेंट साइन चेंज करता है और अगर हम उसका इलास्टिक कर्व बनाएं तो जिस पॉइंट पर पॉइंट ऑफ कॉन्ट्राफ्लेक्चर है उसी पॉइंट पर इलास्टिक कर्व भी अपना कर्वेचर चेंज करता है. सो द पॉइंट वेयर इलास्टिक कर्व चेंज इट्स कर्वेचर इज नोन एज द पॉइंट ऑफ इन्फ्लेक्शन. गॉट इट? Our next concept is internal hinge. Internal hinge को समझते हैं. When the hinge is provided in between the member, then that hinge is known as the internal hinge. Internal hinge को समझने के लिए I have drawn a figure here. This is a propped cantilever beam subjected to a internal hinge. Shape of the internal hinge looks like this. The property of internal hinge is that at the internal hinge bending moment is zero. So we can say internal hinge provide us a compatibility condition so that we can solve statically indeterminate beam which have 1 degree of indeterminacy. This is the benefit of internal hinge. That the bending moment at the internal hinge is zero. अब क्वेश्चन ये है कि सर इंटरनल हिंज पर बेंडिंग मोमेंट जीरो क्यों होता है, तो वो समझते हैं. इंटरनल हिंज will not provide resistance against the rotation of the member. Internal hinge will not provide resistance against the rotation of the member. That's why bending moment at the internal hinge is zero because it will not resist the rotation of the member. Now second concept is link. The shape of link looks like this. This is the link. This portion is known as the link. What is the property of the link? Link carry only the axial force. That is, this link can carry only the axial force. Axial force means the force which is applied in the axial direction of the member. The force which is applied in the axial direction of the member is known as the axial force. So, link only carry the axial force. At point V and C, the bending moment will be zero. The bending moment at point B and C is zero. So this is the concept behind the link. So this is the end of this video. Hopefully you people learned so many good concepts in this video. These concepts will definitely come in your competition exam. With this expectation, thank you.